The Kanlaon Volcano in the Philippines just produced a large explosion, and I think I know why it was triggered. This specifically occurred at 4:39 p.m. local time yesterday, sending many thousands of tons of rock high into the sky and hurling large boulders beyond its crater rim. Since part of the eruption column was too dense to rise on a buoyant column of hot air, it collapsed back to the ground, generating a series of pyroclastic flows which scorched areas up to 750 meters or 2,461 feet away. For the next 2 minutes, the eruption continued as the associated plume climbed higher into the sky, eventually reaching an altitude of around 15,000 feet. Light amounts of ash subsequently fell on various towns to the west as much as 35 kilometers away. Schools were subsequently closed for the day in at least 3 towns, and authorities reiterated that everyone living within the 4-kilometer exclusion zone should evacuate. What had just occurred was Kanlaon's 6th large eruption since its broader eruption began all the way back in June 2024. And of these 6, the latest eruption would rank as the smallest of the group. While this, for all intents and purposes, was not a truly large eruption by world volcano standards, it was large in the context of the Kanlaon volcano specifically, since its eruptions as of late typically look more like this: small, weak, and intermittent low-level ash emissions for minor eruptive activity. The reason why such a large explosion occurred on February 19, 2026 is simple. A notable plug largely blocked the magma conduit, causing pressure and volatiles, perhaps even some magma, to build up until it broke its way upwards through the overlying rock. I make this assertion due to the recent change in both the number of volcanic earthquakes and sulfur dioxide emissions Kanlaon has produced, the latter generally being associated at high levels with the presence of shallow magma. After sulfur dioxide emissions peaked on February 16th, a continuous drop occurred as the newly formed plug blocked the majority of gas from breaking through it. This even reached what appeared to be a record low in sulfur dioxide emissions since June 2024. This occurred at the same time as an increase in earthquakes in the hours before the eruption happened, potentially signaling early efforts of building volatiles to break through the plug. These plugs could be literally located at the bottom of Kanlaon's summit crater, or could theoretically exist multiple kilometers underground. Regardless, the eruption which occurred was volcanian in nature, hence the presence of pyroclastic flows. Now, we need to see if the plug has fully or just partially broken, because either more typical and weaker eruptive activity could follow, or some additional similar magnitude volcanian eruptions. In my opinion, I think the former is far more likely. Previously, the shortest length of time between 2 larger eruptions at Kanlaon was a little over a month. Kanlaon's broader eruption, which began in June 2024, is technically the largest and most explosive the overall volcano has produced in recorded history, registering in as a lower-end VEI3 on the 0 to 9 Volcanic Explosivity Index. However, that only marks its peak intensity, and most of its prior historical eruptions, although explosive, were only small to moderate in size. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.